Now members, we have another subheading called propagation of errors. Now propagation of errors include addition, subtraction, multiplication, and also division, or what some people call quotient. So let us see what happens if you have addition. How do you get errors when you're adding some values? So let x and y be exact values approximated to x and y with errors ex and ey respectively. You know that when I have an exact value, it will be equal to the approximate plus the error, because you know that our error is equal to the exact minus approximate. So if I take this side, I'll be having error plus approximate equaling to exact. In simple terms, that's what we are doing here. So if I have also y, it will be this plus this, as simple as that. Now it means that this error, you get the exact minus the approximate, as you can see here, as it's stated there. Now, if I get the sum of exact values, this is what I need. Then the sum of approximate values, this is what I have. These are small x and y, then these are capital X and y. Now, I want to get the error in that sum. It means that to get the error in the sum, what we do, we say, allow me to write this as error in x plus y. It's going to be now exact sum. What is our exact sum? Is this. So allow me to write x now plus y. Then we are subtracting off the approximate sum. Because the error said you get the exact minus the approximate. That's why now I'm subtracting off the approximate sum, which is x plus y. So if we open the brackets, this will give me capital X, capital Y, minus x minus y. Put x's cross, so I have x minus this, then plus y minus the small y. Now you see that the whole of this is given by this, so this will be now ex plus this one will be ey when you go at this. So now, if I want to take the absolute error of these two, we get the error here, we get the absolute side and absolute there. So implying that this is my e, error in the sum of capital Y and capital X. So if I want to take the error, this will be now magnitude of e x plus e y. Now, using modulus, we always know if I have, not. I don't know where I should put this not. Not. Let me put this not here. If I have a plus b, this is going to be less pi equal to magnitude of a plus magnitude of b. You get any two numbers, you add them, then you subtract them. Consider A to be 3 and consider B to be negative of 4. You see, if I substitute here, I'll be having 3 plus negative 4, which will give me a 1. Then I have A magnitude plus B magnitude. You see, I'll be having a 7 with ease. I think it's that always this is greater than, so implying that always 3 plus negative 4 can be greater or equal to, separate, then plus. I think we have seen a good example there. So now, it means that now, if I separate this, now this will be equaling to, be careful here. When I have this now, I'm going to say this one is less or equal to, not do that direct. Let me take you slowly. Let me take you slowly here. So, when I have that, I'm going to say this one is equaling to ex plus ey, but this one said is less or equal to e of x plus e of y. Now, if this is equal to this, and this is less, this is the step we have here. ex plus y. So here is the concluding statement here. Note, if this is equal to this, and this is less or equal to this, it means that now also this is going to be less or equal to this. Imply that now my e of x plus y is also going to be less or equal to e x plus e of y. What does it mean? It means that now the maximum possible error we can get in a sum is going to be this. So if I say this as ex plus y is going to be the maximum is going to be equal to that. Why am I? Because I'm taking it to be the maximum possible error we can take. Because it is great less or equal to, meaning the maximum error you can get, the maximum sort of error you can get is when it's equal to this, when I cover this. It's when equal to that. I think you can see it. But you can get more which are below it when I cover this here. I think it's below. But the maximum is when it's equal to that. So that's why I'm adding now ex plus ey. And so that one, it implies that therefore the maximum absolute error is going to be equal to e of x then plus e of y. Now, we can also take it as to be the absolute error, equaling to the absolute error. Absolute error. So here, the conclusion is, if we want the maximum, it means that if we want the maximum, we need it when it's equaling to that, because that's the maximum we can get. Now from here, we can come and we get our relative error. So our relative error is saying is the same as the absolute error over the exact. So it's saying it's the same as absolute error over the exact. So this will be our absolute error. We have seen it's this. So ex plus ey, the whole over our exact. What was our exact? Our exact was the sum of this one. Okay, so when I want the percentage error, it's going to be now, we get now relative error and 100. This would be ex plus e of y, the whole over x plus y times 100. Now, I give you a nice example here. Example, if this is this, and y is this, find the absolute error. In simple terms, what we do, you don't get the absolute error, you need the error in x, you need the error in y. So you see my x is 3.14, implying that now my error in x, it will be 0.5 times 10. So this one was rounded off to 2 decimal places, which will be 0.005. When I get now my x, I mean my y is 7.0. Now my error in y is going to be 0.5 times 10, our negative 1. Because this was rounded off to 1 decimal place, which would be 0.05. It implies that now, if I want my absolute error, part A, absolute error, I'll get now, I said you get e in y in x plus the modulus of the error in y. So it's that is very okay by getting, this will be, now our e in x is 0.005 plus our e in y, we are taking the modulus of these two. Modulus of 0.05, which you see this is going to be 0.005 because the modulus of the positive is the same as that same number, which is going to give us 0.055. I think now we can easily calculate that. So now my percentage error, part B, percentage error is going to be now these two things, E of x plus E of y, now over x plus y times 100, which will give you, the whole of this is 0.055 divided by now, when you get this 3.14 plus 7.0 times 100. And the answer you are getting there will be 0.055 divided by, and you add the 7 here, you get 10.14 times 100. This would be 0.54%, and that would be your answer. So that's what we get. That's how you get the error in sum or errors in addition. But the conclusion matters from this step to that. Now I'm going to get, in the next lesson we are going to see errors in subtraction.